Hello guys, so we are going to continue discussion with respect to statistics. In this video, we are going to solve a problem or perform hypothesis testing using chi-square test, which is also called as goodness of fit. Okay. Now, let's go ahead with this particular question and let's see what all information we have, and then we'll follow step by step to solve this hypothesis testing. Okay. And for this, we really need to use a table which is called as chi-square table. Okay. So in 2010, the census of the city, the weight of an individual in a small city were found to be the following, right? Less than 50 kg, 50 to 75, greater than 75. Like less than 50 kg were 20%, 50 to 75 were 30%, and greater than 75 was 50%. Now in 2020, the weights of n is equal to 500 individuals were sampled. Now see, in 2020, you have sampled the weights, right, of some 500 individuals. And below are the results, okay? Below are the results. Now in this particular case, you will be able to see that less than 50 is 140, 50 to 75 is 160, and greater than 75 is 200. If we sum it up, it is basically 500. Now based on this sample, we need to see whether there is a population difference with respect to 2010 and 2020. Okay. So using alpha is equal to 0.05, would you conclude the population differences of weights has changed in the last 10 years? And remember, this is my sample data. And with this, I want to make an assumption of the population in 2020. Okay. This is what we are doing. And for this, we will specifically use chi-square test because I have three categories. Okay. Now let me go ahead and let me show you how we can solve it. First of all, I will take this data. This is my 2010 data. Okay. This is my 2010 data. So let's go ahead and write it down over here. So this is nothing but my 2010 data. And this data, I will say it as expected data. Okay. This is the original data or population data that we have with respect to the information, right? Now coming to the next one, which was this sample data. This data, we usually say it as observed data. Okay. So this data is of 2020. And this is basically my observed data. Okay. And this is for sample n is equal to 500. Okay. Now, with respect to this observed and expected, see, expected is still in 20%, 30%, 50%. But if I say what would be the expected data in 2020 based on this sample, okay? So what I will do, see, I'll copy the same thing. See, or I'll make a bigger cell so that you'll be able to understand. So let's say this is my cell. And now I really want to form my expected data based on the new sample that I have, right? If the sample was same, so less than 50, 50 to 75, and greater than 75. Now in this case, when I try to find out my expected data, how do I find out? See, in 2010, 20% was expected before less than 50 kg. And over here I have 140, right? From this samples. But the original expected was how much? It was simple. I will just multiply 0.2 multiplied by 500. So this is nothing but 100, right? Now coming to the next cell, 50 to 75, right? Now in this scenario, you can see in 50 to 75, over here, you will be able to see from the sample 160 is there, but my expected was 30%, right? So I'll try to multiply 0.3 multiplied by 0.160, okay? Sorry, not 0.160, 500 because my sample size is 500. So here I will probably be getting how much? 150, right? And finally, you'll be able to see over here it was 50%. So I will multiply with 500. So the total I'm going to get is 250. Now this is my expected information, right? Based on this sample, considering the 2010 census, right? Now what I am going to do over here is that based on this problem statement, I'm going to now apply a chi-square test and find out whether this differences is whether there is a differences between 2010 and 2020 census with respect to the observation of weights. Okay. So the next step, what we'll do, obviously, we'll go ahead and write our null hypothesis. Now, null hypothesis is very simple to write in this case. So my null hypothesis, it's saying that at 0, the data meets the expectation. Okay. Then what is my alternate hypothesis? So obviously my alternate hypothesis will be H1 and it will be the reverse of that. The data does not meet the expectation. It is the same thing, right? It meets the expectation, does not meet the expectation, right? That is what alternate hypothesis will be. Now the second information that I have, I always know my significance value. It is nothing but 0.05. So I can also derive my confidence interval. My confidence interval will be 95%. Okay. Now the next thing in chi-square test is that when you observe the chi-square table, you also need to calculate the degree of freedom. So the degree of freedom over here, in order to calculate, I have to take df is equal to number of categories minus 1. So how many categories I have? 3 minus 2, right? Minus 1 is just 2. 3 categories I have. 1 category, 2 category, 3 category. Okay. Now this is clear. Okay. Now the fourth step is basically called as decision boundary. Now see guys, in Z test and T test, whatever things we used, we specifically use a symmetrical distribution. But in the case of chi-square test, we don't have a symmetrical distribution. Instead, our distribution will look something like this. It will look something like this. Okay. Now we need to find out one critical value. Okay. Based on this, right? My critical value. Based on what? Based on my significance level. So this will be 0.05 and this will be 95% confidence interval. Okay. So I have to find out this critical value, and if my test statistics, whatever chi-square test statistics I apply, if it is greater than this critical value, then we reject the null hypothesis. If it is present in this particular area, then we accept the null hypothesis. So this part is basically called as rejection area, and this part is basically called as acceptance area, right? So this is what we are coming up with. And this thing, from where do we get the critical value? For that, we will be using degree of freedom and this alpha value, and we'll check it from our chi-square table. Okay. So let's go ahead and see with respect to the chi-square table, and you'll get an idea like how does a chi-square table look like. Okay. So this is how a chi-square table looks like. You can just go and search for chi-square table PDF and you will be able to get this. Now here you can see on the top, you all have that significance level value. So right now my significance is 0.05. My degree of freedom over here is 2. So based on this, I'm going to get 5.991, right? So over here, my critical value is nothing but it is basically 5.991. Now I can make an assumption saying that if my chi-square test is greater than, chi-square test notation is given like this, 5.99, we will reject the null hypothesis, else we fail to reject the null hypothesis. So what I'm saying that if I get a chi-square test greater than this critical value, so my critical value is nothing but 5.991, then we are going to reject the null hypothesis because we are coming to this extreme end. This area is the acceptance area. Okay. Now let's go ahead and calculate the chi-square test. So this is my fifth step. We calculate chi-square test statistics. Okay. Now in order to calculate, I have this value sigma observed minus expected whole square divided by expected. Okay. So this is the entire formula of chi-square test statistics. Again, I'm going to repeat. Summation of observed minus expected whole square divided by expected. So we are trying to compare the observed and the expected values. So over here, what I'm going to do, I'll just copy this both data that I have and I'll paste it over here. Okay. Let's see. So for pasting, and I'll make it a little bit small so that we'll be able to see the data properly. So here is my data. Okay. Here is my data. So if I probably see this, here is my data. Now with respect to this, I will go ahead and do this. Okay. Understand this value is observed. This value is expected. Okay. So I'll write summation. So over here 140 observed minus expected. So 140 minus 100 in this 50 range. Okay. So it will be whole square plus observed 160 minus 150 whole square plus 200 minus 250 whole square. Now every term will get divided by your expected value. So this will be 100, this will be 150, and this will be 250, right? Further we go ahead. So this will be 1600 divided by 100 plus it will be 100 divided by 150 plus it will be 50 square, 2500 minus 50 square divided by 250. So finally you will be able to see all my values over here, and we get nothing but 16 plus 0.66 plus 10. And overall, if I see the value, it will be nothing but 26.66. So my chi-square is nothing but 26.66. Now we'll go over here and again talk about my decision rule. Now my decision rule said that if my chi-square is greater than this 5.99, right? If my chi-square is greater than 5.99, we reject the null hypothesis. So what we are going to do? We are going to compare. Over here, 26.66 is obviously greater than 5.99. That basically means it falls in this region. See, 5.99 greater than 5.99, this region, right? So what we do? We specifically reject H0, right? We reject the null hypothesis, right? So finally, what kind of, or we can also write like in this, right? Let's say if this value was less than this, we will say that we failed to reject the null hypothesis. Okay. So finally, our answer or our conclusion is that the weights of 2020 population are different than those expected in the 2010 population. So this is the assumption we are actually making, and obviously just by seeing the table also, right, you can understand that there is obviously a huge difference, right? In 2020 and in 2010, right, there is definitely a very good amount of difference, right? So yes, this was it from my side. I hope you like this particular session. I will see you all in the next